exercise 5. Let us see this small tutorials and see what this question has to do. We have the output and revenue situation of a hypothetical firm, and then we have the output ranging from 0, 1, 2 to 6, and then we have our marginal revenue. The first question says we should determine the total revenue and average revenue of this firm. How can we determine total revenue from marginal revenue? We rather do determine marginal revenue from total revenue always. But you can go about it. It is simple. If you understand the concept, we know that marginal revenue is the extra revenue that we generate when one additional unit of output is produced. When there is an additional output produced, the extra revenue that we gain or generate from that one additional unit of output is what we call marginal revenue. And if I were producing nothing, then the extra revenue I would get from producing nothing will be nothing. That is why at output 0, marginal revenue is 0. And then when I start producing one thing, if my additional revenue, that is marginal revenue, for producing one commodity is 100, then what should be my total revenue? When I was producing nothing, my marginal or extra revenue was nothing. Now that I've started producing one item, the extra revenue I have gained from producing that one item is 100. So what is my total revenue from producing one item? It should be 100 as well. Simple, it is 100. So our total revenue here is 100. When we are producing nothing, output will be nothing, and then total revenue will be nothing. So in order to continue from the second output level, how to get the total revenue at the second output level? We know that this marginal revenue of 60 here was gotten by looking for the difference between this total revenue that exists here and the previous total revenue. Because we calculate marginal revenue by saying that we say marginal revenue is equal to change in total revenue all over change in output. But we also say that whenever output is changing by persistent or consistent values of 1, we can also calculate marginal revenue by saying that it is total revenue 1 minus total revenue 0. That is the present total revenue minus the previous total revenue. And then we continue by saying it is total revenue 2 minus total revenue 1. So therefore, since we already know the marginal revenue here, and we do not know the corresponding total revenue, and the formula for calculating this marginal revenue, which is 60, is present total revenue minus previous total revenue, should give us this marginal revenue. According to this formula, we know that we just need to ask ourselves, what is that value that when I subtract 100 from there, it is going to give me 60? Because at the second output level here, TR2 now will be what? TR2 is unknown. Let's call that unknown that it is X. TR2 here it is X minus TR1, and TR1 here is 100. We should give us our marginal revenue, and the corresponding marginal revenue is what? 60. So if you want to solve for X, let's call this total revenue that X. If you want to solve for X, what do? We say X is equal to, we bring like terms together. 100 crosses the equality sign to make 60 here. So we have X is equal to this 60 plus 100. Because when negative crosses the equality sign, it changes to positive. So X is equal to 160. Which means that our total revenue here is 160. And we can prove that we are right. To show that our total revenue here is 160, what we do is that let us pretend that we do not know this 60, so that we calculate marginal revenue. If we should pretend that we do not know that 60, we will say that marginal revenue is equal to change in total revenue all over change in output. So this change in total revenue here is 160 minus 100. 160 minus 100 divided by change in output, 2 minus 1. 2 minus 1. 160 minus 100 gives us 60. 2 minus 1 gives us 1. 60 divided by 1 gives us 60. That is it there. So that is how you get total revenue if you are given only marginal revenue. If you realize that your output is changing by corresponding values of 1 as it is here, you can also do diagonal summation. What do I mean by diagonal summation? What you do is you take, like to have this 160 here, we had 60 here. We just take the corresponding marginal revenue at the point where we are looking for total revenue and add to the previous marginal revenue. That is 60 plus 100. It gives us 160. Or you can do cumulative summation of marginal revenue values. 100 plus 60, it gives you 160. To go to the next, you take 20 plus 160, it will give you 180. Or what you do is you take 100 plus 60, which is 160, plus 20, 180. Or you just say 20 plus 160, you get this one. And then, what you can also do is, to get the next one, 20 plus 180 gives you 200. Or you say 100 plus 60, 160 plus 20, 180 plus 20 again, it gives you 200. That is the corresponding total revenue. You get to the next, you do the same thing. 0 plus 200, it gives you 200. Or you sum again, 200. You get to the next, negative 20 plus 200. If you are owing me 20 things and you have 200, when you must have paid me, you'll be left with 180. Or you say, this plus this plus this plus this plus this plus that, it gives you 180. So that is how you get your marginal revenue. Okay, so we are done with marginal revenue. How do we get average revenue? We know that average revenue simply refers to price. That is another appellation for price. Average revenue simply refers to the income we generate from each unit of output. And if we were under perfect competition, average revenue would have been the same as marginal revenue, and the values would have been constant at all output levels. But we can see that marginal revenue exists in three forms. Marginal revenue is positive and falling, 0 at some point, and it turns into negative. So it shows that we are under imperfect competition. So what we are going to do to get average revenue is we use the normal format. Average revenue is normally total revenue divided by output. So we just take these values here and divide by the corresponding output levels. 100 by 1, we have 100. 160 by 2, it gives us 80. 180 by 3, it gives us 60. 200 divided by 4, we have 50. And then 200 divided by 5, it gives us 40. And then we have 180 divided by 6, it gives us 30. So that is how you determine your average revenue. And then now, they say illustrate the MR, AR, and TR curves on the same diagram. So let us see how to draw all of that on the same diagram. Now, this is paper 3. And they did not say you should plot. They have said you should illustrate. But while illustrating, since we have statistical values here, while illustrating, we need to apportion those values in the right places. Let me show you what I'm talking about. With the use of diagrams, we have total revenue, and marginal. So this one is revenue, and then we have revenue and output too. Okay, we know that the total revenue of a firm's under imperfect competition has this shape, and our highest value of total revenue here is what? The highest value of total revenue here is 200. So we have 200. We are not plotting to scale, we are just sketching. Yet we need statistical backup just to illustrate what we have on the table. So we have 200, and then at that same point where total revenue is maximum, we want to show that marginal revenue at that point is going to be 0. Look at marginal revenue. Marginal revenue is 0 when total revenue is maximum. So we have MR being 0, and that is at the feed output level. At the feed output level. So at the feed output level, total revenue is highest at 200. Marginal revenue is 0 at the feed output level. And then at that same feed output level, let us see what happens to our average revenue. Our average revenue at the feed output level is equal to 40. This is it. It is equal to 40. And then we can use this diagram to explain the relationship that exists between marginal revenue and the price elasticity of demand. Let us see. Let us answer the third question, then we will come back to that diagram. It says, over what range of output is demand elastic, unitary, or inelastic? Demand is elastic over a portion of output where average revenue is positive and marginal revenue is rising steadily, and total revenue is rising steadily, not marginal revenue, please. Total revenue is rising steadily, while marginal revenue is falling, yet still positive. I take that all over. The demand for a good is elastic when its marginal revenue is positive and falling, while its total revenue is steadily rising. So therefore, we are going to see where total revenue is steadily rising here. It rises from 100 steadily to 200. And also, we must make sure that our marginal revenue is falling and it is positive. So marginal revenue is falling from 100 to 60 to 20 to 20 again, and it is positive over this range of output. And then we also see that average revenue is also falling. So therefore, it shows that from this portion to that, PED is greater than 1. This good is elastic in demand because before the feed output level, that is from the first to the fourth output level, marginal revenue is falling and it is positive. Total revenue is rising persistently. So this good is elastic. And then the good becomes unitary in demand, that is PED being equal to 1 whenever total revenue is highest and marginal revenue is 0. So we see marginal revenue is 0 here at the feed output level and total revenue is at its maximum point. That shows that the good is unitary in demand. And then the price elasticity of demand becomes less than 1. That is fairly inelastic whenever marginal revenue becomes negative. And then total revenue begins to fall. Total revenue has started falling from 200 to 180, and then marginal revenue has turned to be negative. You see, total revenue is falling, and then marginal revenue has become negative, which shows that the right hand side of this diagram, that is from here to here, PED is less than 1. So this is fairly inelastic, this is unitary, this is fairly elastic. That is how we show the relationship. Thank you. We are going to continue in our next slot.